Assalamualaikum and hi. We are from Group 5. We will present about our project Cholesky method. First, my name is Nur Fitriani binti Januddin alias Januddin, number matrix CF190046. I will present about introduction of our project. This study describes the use of the numerical method in civil engineering area by correcting a problem statement that needs to be solved using any numerical method which is learned in BFC 24203 Civil Engineering Mathematics 4. Our study used Cholesky method based on the problem statement. Cholesky method, also known as Cholesky decomposition or Cholesky factorization, is decomposition of a Hermitian. This composition is invented by Andrew Louis Cholesky, a French artillery officer, in the context of his work in the geodesic section of the Army Geographic Service. Cholesky decomposition is a positive defined matrix that written as a product of lower triangular matrix and its conjugates transposed to solving system of linear equation. In this method, a matrix A for AX equal B can be decomposition of the form A equal LL power T, where L is a lower triangular matrix with real and positive diagonal entries, and the L power T denotes the conjugate transpose of L.
Problem statement. The Hooke stress is an important factor to consider when planning the suitable pipe for a water distribution system. The failure caused by this stress could cause the pipe to split in half and burst perpendicular to the greater stress. As a result, the Hooke stress of internal pressure must be greater than the pressure of water passing through it. For this project, we need to make a research about the problem related to civil engineering field, which can be solved by choosing numerical method, and for our group, we choose it Cholesky method to solve it. Objective of our project: to solve about the problem related to civil engineering field using Cholesky method.
Hello doctor, my name is Nandini. I will present the Phyla table. These are the facts listed down from the problem statement. The first fact is design a water distribution system. For it, we will need to determine the shape of pipe. Second, find the stresses of the cylinder. So these are the values we will be assumed to substitute into the equation. Next is Cholesky method applied to solve the problems, where we use 3 times 3 type of matrix in this problem. Next is about learning issues. So first of all, apply the suitable simultaneous equation, where we choose the correct values to put into the simultaneous equation. The second learning issue is determine Hooke stress and apply the Hooke stress equation to find the maximum stress. And next is we calculated values for the Hooke stress equation from Cholesky method. These are the steps we used in the Cholesky method to solve the problem. The step 1 to solve the Cholesky method is create matrix A, X and B, where it is the simultaneous equation. Step 2 is write matrix A as A equals to LU. This is the lower triangular matrix and upper triangular matrix. Step 3, solve for L and U as L and LT, where we will times L and LT to put into a one matrix, so we can compare the A elements and LLT elements to find the value. After finding the values by comparing the elements, we can substitute back the solved values into matrix L and U. 4 is write matrix equation L, y equals to B, where we can solve the y value by forward substitution. Lastly, the step 5 is write matrix equation as U x equals to y, so we can solve the x values by backward substitution. To solve the Cholesky method, we will continue with Hooke stress equation. This is the formula will be used to find the maximum stress. So we will substitute the Young modulus, Poisson ratio. C2 and C3 are the solved values from the Cholesky method. V is the Poisson ratio and R is the radius. After substitute all the values, we can find the maximum stress.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sharifin Imam Sabri. Okay, so I will present about the literature review. Okay, so first off, the compound cylinder are used in a variety of applications, including water distribution, hydraulic presses, 4G presses, power plants, gas storage, chemical and nuclear plant, also military uses. A water distribution system's goal is to safely supply enough drinking water to end users at high enough pressures to allow or support a wide range of human needs. Okay, this to ensure that the compound cylinder's maximum stress is larger than the pressure of the water flowing through the pipe. The water pressure in the distribution system should be not less than 170,000 Pascal as a rule of thumb. Distribution line in many high value areas are designed for a normal pressure of between 414,000 and 482,000 Pascal. As a result, the cylinder pipe's hoop stress is one of the most significant factors to consider when selecting a pipeline, as hoop stress is the stress that happens along the pipe circumference when pressure is applied. Okay, I think that's all from me. Thank you.
For the calculation, we use Cholesky method to find the maximum stresses in the pipe. Before that, we already identified that method that we use is symmetric method, which is it is suitable to apply Cholesky method. Okay, for the first step, we will compose metric A equal to L times L transpose, which is A would set to metric L times metric U. This is metric L and this is metric U. Then we can solve for L transpose. This for the L transpose, we can use this formula to find the unknown variable. Okay, for the second step, from A x equal to B, which is we already know that A equal to L times L transpose, so it can be Ly equal to B. Then we can solve for Y. To find the unknown variable, we will compare with the metric A, and then we can get the unknown variable, and then we can arrange for metric L and metric U. For equation Ly equal to B, we can solve by using forward substitution to find the value of Y. And then we can find the value y1, y2 and y3. For the x, we from equation u x equal to y, we can solve by using backward substitution, and then we can find the value of s1, s2 and s3. For that, there are two answers, which is in terms of y and in terms of x. Okay, lastly, to find the maximum stresses in the pipe, we can insert the value of elasticity, velocity and radius in the equation. There are two answers to get the maximum stresses in the pipe, which is to identify the maximum stresses by using backward substitution or substitution value. For the backward substitution value, we got 267 megapascal, and for the forward substitution value, we got 299 gigapascal. For the discussion, we can conclude that we will be able to find the maximum stresses in the pipe by using Cholesky method. The maximum stresses or stresses on inside radius of water cylinder value is greater than the standard water pressure, which are between 414 Pascal to 482 Pascal. Based on the result that we obtained from the calculation previous, we determine that there are two stresses value, which are 267 megapascal and 299 gigapascal. So we can conclude that the maximum stresses in the pipe, we can use 299 gigapascal, which is the value of forward substitution value.
From this study, we can conclude that Cholesky method can be used in civil engineering field, which is where there are some cases that require numerical method in order to calculate related parameters. Cholesky method helps a lot in finding exact solution of many known functions that cannot be solved using analytic method. This study showed that Cholesky method able to determine the maximum stress and on inside radius of outer cylinder value in pipe. Cholesky method provide an alternative solution that will ease the calculation process and help engineers to solve any cases related to civil engineering field in shorter time but with accurate results. That's all from us. Thank you for listening. Bye.